In section 8.2, we're going to learn how to multiply polynomials. And there are multiple different ways to multiply polynomials. I'm going to show you examples of each of those different methods. But the first thing I want you guys to realize is that, and remember, is that anytime you have a set of parentheses, anything that's in front of that set of parentheses gets multiplied into that set of parentheses, and it's called distribution. So the first method is just to use the distributive property. And this is the method that I recommend that you do anytime that you have a monomial times a polynomial. And the way we're going to go about multiplying is we are just going to use the distributive property. We're going to take the first term times the first term, plus the term 4x squared times negative 3x squared, plus 4x squared times 4x, plus 4x squared times 5. So by using the distributive property, all I do is I bring what's outside the parentheses and multiply it by everything that's inside of the parentheses. Then I multiply number times number. 4 times 2 is 8. Then the variable times the variable. X squared times x cubed is x to the 5th. 4 times negative 3 is negative 12. X squared times x squared is x to the 4th. 4 times 4 is 16. X squared times x is x cubed. 4 times 5 is 20. And then just the next squared. So this is the final answer. This is the intermediate work step. However, I do not need you to write out that intermediate work step. If you are going to use the distributive property, all I want you to do is, as you do each multiplication, just show me what you're doing. You're going to do 4x squared times 2x cubed. 4 times 2 is 8. X squared times x cubed is 8x to the 5th. Then the next term. It's 4x squared times negative 3x squared. 4 times negative 3 is negative 12. X squared times x squared is x to the 4th. Then our next term is 4 times 4 is 16. X squared times x is x cubed. And then the final multiplication I have is 4x squared times 5. 5 times 4 is 20. X squared. Please note that you're going to do the multiplications of the number of terms of the first polynomial times the number of terms of the second polynomial. So the first polynomial has one term, it's a monomial. Second one has 4 terms, so I ended up doing 4 multiplications. So that is the first way to think about it, is by using the distributive property. My recommendation is that you use this property anytime you have a monomial times a polynomial. You may skip the intermediate step as long as you show me the multiplications that you are doing. One quick check is to make sure that you have the right number of terms. However, sometimes you may end up canceling some terms out and get a 0, so this number may be off. This will be the max, well, this will be the number of multiplications you do. The number of terms you do have is going to be dependent upon what the powers are in here, but you're always going to do this many multiplications. For the second example, I'm going to do a binomial times a binomial, and I'm going to do this using 3 different methods. The first method, again, is going to be the distributive method. And we remember the distributive method, anything that's in this parentheses, each term in here, you multiply by what's outside of it. So I have the 4x times 2x plus 3. Then I have a negative 5 times the 2x plus 3. And again, I have the distributive property. I've got something in parentheses multiplied by a number. So each term inside here, I multiply by the number outside. So So I have 4x times 2x plus 4x times 3. Then I have a minus 5 times 2x and a minus 5 times 3. And then I do these multiplications. 4x times 2x, 4 times 2 is 8. X times x is x squared. 3 times 4 is 12. X. Negative 5 times 2 is negative 10. X minus 15. Unlike the previous problem, on this problem I have two terms with x's in them, so I need to combine these like terms. I have 12x minus 10x, and that is 2x. And every other term stays the same. And my final answer would be 8x squared plus 2x minus 15. And that's using the distributive method. So notice the distributive method, I had to use distribution twice because I had a binomial times a binomial. There is a shortcut for the distributive method if you have a binomial times a binomial. And I'm going to show you with the same problem. And it uses the abbreviation FOIL. And again, this is just the distributive property using an abbreviation for the shortcut. It means the first term times the first term, which would be 2x times 4x. The O stands for outer, so that would be 2x times negative 5. The I stands for inner, so that would be 3 times 4x. And the L stands for last, and that would be 3 times negative 5. And I'm going to do these multiplications. Please note that they are the exact same multiplications that I ended up here using the distributive property, just these two in different orders. 4 times 2 is 8. X times x, x squared. Negative 5 times 2 is negative 10. X. 3 times 4 is 12. X minus 15. Combine like terms. Negative 10 plus 12 is 2. So I have 8x squared plus 2x minus 15. Please note again, I had 4 multiplications. 2 times 2 is 4. I ended up with 4 multiplication steps. I'm going to do this problem 2 more times. The next time I'm going to do it, I'm going to do the table method or the box method. And then the following time, I am going to do using regular multiplication. So for the table method or box method, you are just going to make, in this case, a 2 by 2 table where we're going to do the multiplications with it. So I'll show you how to set it up. I want a 2 by 2 table. So there's 2 by 2. Above the columns, I'm going to put each term here. Down beside the rows, I'm going to put each term here. And then I'm going to fill in the table by doing the multiplications. Another name for this would be the area method. So 2x times 4x is 2 times 4 is 8. X times x is x squared. 3 times 4 is 12. X. 2 times negative 5 is negative 10. X. And 3 times negative 5 is negative 15. And now we combine like terms. Notice that both of these terms have x's in them. 12 minus 10 is 2. So I copy 8x squared plus 2x minus 15. And the final method I'm going to show you is the way I prefer to do it because it works for every single method. It's going to use about the same amount of room as the table method for binomial times binomial. But when you start to get like 4-term polynomial times 4 terms polynomial, this last method would probably be the preferred method. And all you're going to do is you're going to set it up like regular multiplication. And you are going to multiply like normal. You're going to take this number times each number up here. Negative 5 times 3 is negative 15. Negative 5 times 2 is negative 10x. 4 times 3 is 12x. And 4x times 2x is 8x squared. And then you add your columns. And I end up with 8x squared plus 2x minus 15. So I've done that problem 4 different ways. I use distribution, showing each distributive step. I use the FOIL shortcut for a binomial times a binomial. I did the table method, and then I used regular multiplication method. So for my next example, I'm going to do a binomial times a trinomial, and I'm only going to do the table method and the regular multiplication method because FOIL does not work, and then the distributive property gets really messy when you have anything more than a binomial times a binomial. So give me a second to erase the board and write the next problem. So for the last worked out example, I'm going to do is the quantity x squared plus 2x plus 1 times the quantity x plus 2. I'm going to make the table method. So I'm going to make a 3 by 2 table. I'm going to write x squared, 2x, 1, and then x and 2. Now I'm going to do the multiplications. X squared times x is x cubed. 2x times x is 2x squared. 1 times x is x. 2 times x squared, 2x squared. 2x times 2, 4x. 2 times 1 is 2. Combining like terms, I have x cubed plus 2 is 4x squared. 4 plus 1 is 5x plus 2. Notice I had 3 terms times 2 terms. 3 times 2 is 6, and I ended up with 6 multiplications. Now to use the regular multiplication method, I put the term with the polynomial with the most terms on top. And then I just do regular multiplications. 2 times 1 is 2. 2 times 2x is positive 4x. 2 times x squared, 2x squared. 1 times x is positive 1x. 2x times x is 2x squared. And x times x squared is x cubed. Add vertically, I have x cubed plus 4x squared plus 5x plus 2, and you notice my 2 answers match. So the last thing I had to give you for the multiplication is 2 examples to turn in as part of your notes. And those 2 examples are on the bottom of page 505. Guided practices 5 and 6. I'm going to pause the board, write them down on the board so you can see them if you don't have your book with you. So again, the 2 problems that I want you to work out to turn in with your notes are on the bottom of page 505. They are guided practice 5 and 6. Guided practice 5 says the quantity 3y squared minus y plus 5 times the quantity 2y minus 3. And guided practice 6 is the quantity 4b minus 5 times the quantity b minus 2. Remember to do these 2 problems on a piece of paper that was provided for you or on a separate piece of paper. You will turn these in at the beginning of class on the day that they are due.